In this entry, we're going to go over polynomials, what they are, how to classify them, and then how to add and subtract them. So we're going to start here, the definition of a polynomial. So a polynomial is an expression that contains variables, constants, and exponents. Now previously, we've been going over polynomials, but specific type of polynomial that's a linear equation, like x plus 3, right? That's something that's linear. If we were to say it's y equals x plus 3 and make that an equation, it would make a line. That's why we call it linear. But some expressions get more complex than that. And so in this last half of algebra and then leading into algebra 2, we start talking about more complex expressions and more complex equations once we get there. And you'll learn how to solve those and manipulate those and graph those. But first we're going to talk about just in general what a polynomial is and how to classify it. In your packet you should have gotten these two pieces of paper. What you're going to do is cut out along the dotted line here, and obviously the same on the second page, and this is going to turn into a flip chart. So I'll let you pause the video, cut this out, and then I'll show you how to stack it together. Now that you've cut across the dotted line, you should have this. Okay, you're going to flip it over and then move this piece up just a little bit so you see the adding just above the subtracting. Okay, and if you get your papers kind of mixed up and they're kind of all over the place, right, just put your subtracting one down. That's the one that says subtracting at the bottom, and then above it you're going to put the one that says adding, and you're going to leave a margin so that you can see both. Okay, and then the next step is you're going to take your paper and you're going to fold it down so that you also see the what are polynomials with the question mark, and then you see all of the kind of margins here in the tabs that we have for our flip chart. And once you get them all neat and together, fold it down just like so, and you can put staples here and here, and it'll flip up and stay in place. So let's dive into our flip chart here and go over what are polynomials. And we flip this open. We have kind of a generic definition of what polynomials are, but let's get some classification and some vocab in. So a monomial is a specific type of polynomial. And you think of the word mono. Mono means one. Like monotone is kind of one tone. Monomial means one term. Okay, so you're going to write the number 1 right here. Okay. Examples of monomials could be like x, right? Because it's a one term. It could be 7y. That's just one term. You could have just the number 3. That's just one term. You could have something complex like -9 x cubed y squared z, and again that's just one term. Terms are separated by addition and subtraction. So this whole term is just together. So those are called monomials, something that's just one term. Now binomials, you can make the word bi, okay, means 2. So binomial means 2 terms. Examples of binomials could be something like x minus 9. Could have something a little more complex like 7x squared minus 5x. Okay, those are called binomials. Trinomials, which you kind of might get the hint here, trinomials means 3 terms. An example of something with 3 terms could be like 9x squared plus 5x minus 2. And that has 3 terms, right? 1, 2, 3 terms, separated by addition or subtraction. And then there are terms for 4 terms and 5 terms. There's some vocab for that, but pretty much after 3, we always just say polynomial. So if you have many terms, or usually more than 3 terms, we just say it's a polynomial. So an example that you might see of a complex polynomial could be like negative 8x to the 4th plus 5x cubed plus 6x squared minus 8x plus 1. So that's something complex. It's got more than 3 terms. It's got 1, 2, 3, 4, 5 terms in there. Okay. Now some non-examples of polynomials. So polynomials, they have to have positive exponents and they have to have whole number exponents. So you can never really see, if you have a polynomial, you can't see a variable in the bottom, so we can't have any division. So 4 over x, that would not be a polynomial because you can't divide by a variable. One way you can think about that is 4 over x is really 4x to the negative 1, and we can't have negative exponents. Another thing that is not a polynomial is having an exponent as a variable, like 8 to the x. That's also, it's a function. We can certainly graph it. It's a pretty cool graph, but it's not something called a polynomial. Now we've got some extra vocabulary to talk about. So with polynomials, there are certain features of them. So the first feature is called the degree of the polynomial. The second one is the leading coefficient, and the third is the constant. Now you don't always have a constant, so sometimes that's going to be none, but you'll see that for each of these we're going to state what the degree is, the leading coefficient, and the constant. Now, the degree is the highest number of exponents in a term. Okay, so we'll see this one is a binomial, it has 2 terms. This one is a polynomial with 4, a trinomial with 3, okay? But the degree is whatever term has the most exponents. And we use this feature of polynomials because when we compare them, we want to figure out which one is higher. And it's easiest to compare them by saying, well, the degree of this one is this, the degree of that one is this, right? And the higher the degree means the higher the number is going to be when you start putting in values. That's how much it varies. So that's why we use the term degree, why it's an important term for polynomials. So for this first one here, we just have 1 term, so we don't really have to worry about does the other one have any type of exponents or anything like that. The degree of this one is the number of exponents it has. So it's got 1 here and 2 there. So the degree of the whole thing is 3. It's got 3 exponents in total. The leading coefficient is the number that it starts with. So the coefficient on it is 7. So the leading coefficient here is going to be 7. And the constant, well, this one doesn't have a constant, right? A constant would be like if there was +4 or +4 and -5, those are called constants. So this one, there's none. Okay. Now we do the second one. So, what is the degree of this one? This term here, the highest exponent is 2. This one here, the highest exponent is 1. So here's really, really important because I see this mistake a lot. Okay, the total number of exponents here is 2, here is 1. That doesn't mean the degree is 3. Okay, these are separate. It's the highest number that it has, so 2. Okay, these are separate. The reason I combine all these together is they're not separated by an addition or subtraction, right? Those are all together. This is 1 term. Here, this one's 2. This is 1. So the degree of the whole thing is just 2. The leading coefficient is going to be 5. Okay. And the constant here is, well, there's no number by itself, so it's just none. And let's talk about this one. So, The number of exponents in this one is 3, 2, 1, and that doesn't have any exponents. So the highest one here is 3. It's really important, again, that it's not 3 plus 2 plus 1, right? It's not 6. It's 3. So whatever term has the highest exponent. So 3. Leading coefficient is -8. The constant here is -5. Okay. Now this last one here is kind of tricky. When I write polynomials, there's something called standard form of a polynomial, and that means that you're writing it from the most exponents to the least exponents. So you're writing it in order, starting with the highest and then going kind of down the line. So if I start with 6x minus x cubed plus 4, that's not in like greatest to least form. So I have to start moving stuff around. To do that, I figure out which one has the most exponents. It's this one here. It's negative x to the third is going to go first. Then positive 6x. And then positive 4. And at that point, I can start to fill out these sections. So the degree is going to be, this is 3, 1, 0. So the highest one is 3. The leading coefficient is -1. Okay. So I have to change it, because if I didn't change it, this would be the leading coefficient, which is 6, which is incorrect. And the constant here is the positive 4. So that's how we use vocabulary when we talk about polynomials. You're going to use most of this vocabulary in Algebra 2, not so much in Algebra 1. So it's a nice introduction for when you get there and you can start talking about it and feel like you're confident in what you're saying. So we're going to move on to the next video, which is going to be adding polynomials together. The video after that will be subtracting.